All right. Today's going to feel a little bit strange at the beginning because we're talking about probability, but it's like this right here is not probability. We're going to talk about what is called binomial expansion to begin with, and then I'm going to connect it back with probability, how it can be helpful for me there. All right. So binomial expansion could be its own little idea on the side, but it also has ties into probability as well. So that's kind of why I'm grouping it into here. Okay. So on this, it's binomial expansion because we have a binomial. We have x and we have 2 here. All right. So we got 2 things, and we're going to expand it. Now, there's an old picture or whatever that said, it said expand, and somebody gave this as the answer. That's not the expansion that we're wanting right there. All right, we're wanting to actually multiply it all out. All right, and so if I'm going to cube it, then I'm going to rewrite it like that. So x plus 2 times x plus 2 times x plus 2. So to do this, I heard many of you talking about, I'm going to do the box method. You can do the box method, you can FOIL it, but I'm going to pick 2 of those and I'm going to multiply it out. X times x is x squared. 2 times x is 2x. I've got another 2x. And I got 2 times 2, which is 4. So when I multiply that out, I get x squared plus 4x plus 4. However, I still have one more x plus 2. So I've put 2 of them together. I got one more I need to multiply. Okay? I'm going to take the x and now I'm going to distribute it. Now, by the way, if you want to do box method on this, you can still do box method. All right, it's just a bigger box. It's more of a rectangle, I guess you should say. X times x squared, x cubed. X times 4x is 4x squared. X times 4 is 4x. Then take the 2 and do the same thing. Multiply there. I'm going to kind of line them up so I can see them so the x squares go together. That is 8x, and that is 8. So when we finish, we have x cubed plus 6x squared plus 8x, excuse me, not 8x, plus 12x plus 8. Okay? Everybody all right with that? So I asked you to do that. Now, what if I follow this up and I say, okay, let's expand that.
I don't want to.
All right, that's what I get a lot. I don't want to do that one. That one, like, that's a lot. Okay, that's a lot of multiplication to get there. So there's a little shortcut in doing this binomial expansion. Okay, it's a little shortcut, and we're going to kind of look through that shortcut and look at some things. So in your note packet, I gave you this. It's in there on the very last page, or the second to last page. All right. On this one, I have expanded like the first couple out here. I've expanded the first 6 or 7 of these. I didn't mean to do that. All right. Of these as you're going. All right. And so I want to look at the patterns here. Okay. So look through here, and I want you to see if you can kind of see some patterns. If you look right below there, it's got some questions that we're going to answer, so that can kind of help you through that. Okay. So the first thing, anybody see a pattern in this down here? What's getting bigger? Okay, the exponents are getting bigger as we move one way and smaller as we move the other direction. Okay?
It's like the first one, it's going from like big to small, and the second one is going from small to big.
That's correct. So the x's are going from big to small, the y's are going from small to big. So that's kind of the last thing here. What's happening to the exponents of the x compared to what's happening to the y's? The x's are decreasing, and the y's are increasing. Okay? Let's kind of stay with this right here. How does the power of the binomial relate to the number of terms in the expansion? So how does the power relate to the number of terms that I have?
You always have one more.
You always have one more. So if I have a 0 here, then I have 1. If I have 1 here, I have 2. 2 here, I have 3. 3, I have 4, so forth. So it's always one more. Alright? So, always one more. So, on that premise right there, if I go back to the one that I did a while ago, it had a 3, right? What did we end it as terms? We had 4, so that matches. On this one, if I had 15, I'd have 16 terms. So that'd be a pretty long expansion. Okay? Alright. Next. What is the relationship between the power of the binomial and the coefficient of the second term? So the power of the binomial, it's a little bit easier if we will drop down to the farther bottom of this. The power of the binomial in the second term. It's the same thing, right? So the power of the binomial gives me the coefficient of the second term. Make sense? All right, so those are the same. What do you notice about the first and the last terms? They're the same?
The exponents are.
The exponents are the same. All right. So we have like all of one term here and all of the other term at the end. Okay. So we have all of one term. So I'll express that. All of one term. So you have all the x's or you have all the y's. Okay. What's the exponent sum for each term in the binomial expansion?
The exponent.
Okay, the binomial exponent. The binomial exponent. So on that one, if you look here, if this is 3, then that's 3, and 1 plus 2 is 3, and 1 plus 2 is 3, and that's 3 as well. Go down here. That's 6. 5 and 1 is 6. 4 and 2 is 6. 3 and 3 is 6. So they all add up to be the same. I'm going to give you an example that's going to be a little bit more helpful here in a second. Okay? All right. So there are lots of patterns in this as we're going along. Okay? Matter of fact, if I take this right here, this whole pattern, and I take all the x's and y's out, I just leave the numbers. Okay? If I take all the x's and y's out and just leave the numbers, then these are the numbers right here. I've formed them into a little bit different figure. It's more of a triangle. All right? This is called the Pascal's triangle. All right? Named after Blaise Pascal. He was a mathematician. All right? He kind of discovered a lot of these patterns. Do you see any patterns in here that are kind of interesting when I write it this way?
The outside's 1.
The outsides are all 1. Okay?
And like goes like 2, 3, 4, 5.
Okay? And so this diagonal right here goes in order 1, 2, 3, 4, 5, 6. Is that what you're talking about?
Yeah.
Same thing here. That one also goes 1, 2, 3, 4, 5, 6.
And then you add the ones like in between.
Okay. Now, here's the kind of important thing, what I just said. If I wanted to get this 3, how do I get the 3?
1 and 2.
It's in the space between the two above it, 1 and 2. So 1 plus 2 is 3. This 6 right here is in the middle of 3 and 3, which is 6. All right?
10 and 10 is 20.
And then the 10 and 10 is 20. So could we go add the 7th row?
Oh, wait, this.
If we were to go add the 7th row, that'd be a 1. That'd be 7.
21.
That would be 21. 6 and 15.
35.
35. Now, what do you notice about the back end of this? It's repeating. It's symmetric. Okay? So that would be 21, 7, and 1. Okay?
Are there some that are not symmetric?
No, these are all symmetric. Now, sometimes they have 2 in the middle, or they pivot off of like the 20 there, right? Depending on how many terms, but they're all symmetric. Okay? So, the thing about this is I can use this Pascal's triangle to go place the numbers that go in front of all the terms. All right? The only bad thing about this, would you want to do this with the example that I had at 15 as the exponent a while ago? You'd have to go on and continue building the triangle, right, until we get there. And they have to do that, because you're not given the triangle, all right? You'd have to come up with that. I'm gonna show you another way of getting around it here in a second, okay? And so, what I'd like for you to do is, I'm gonna go look at this one. It's kind of on the bottom of the next page. It's B plus F to the 7th. It's B plus F to the 7th, all right? So I'm gonna walk you through this one, kind of on the patterns that we've talked about, all right? And we'll go from there, all right? So if I were to do this, I'm going to take the B and I'm going to put all the B's out front. So I'm going to go B to the 7th. Then I would go B to the 6th. By the way, before I continue, how many terms am I going to have? 8 terms, one more than the exponent. So B to the 7th, B to the 6th, B to the 5th, B to the 4th, B to the 3rd, B squared, B to the 1st, and B to the 0. So I started with B and I worked in a decreasing order. Okay? Now I'm going to go work with F. So over here, F starts 7 here and works the other way. So this is F to the 7th, F to the 6th, F to the 5th, all right, F to the 4th, F to the 3rd, F to the, I need to make these F's instead of B's, to the 3rd, F to the 2nd, F to the 1st, and then F to the 0. Do I really need to put the F to the 0 and the B to the 0?
No.
Because that's what? That's 1. Okay, that's 1, so I don't really need to do. So there's all 8 of my terms. All right, everybody okay with that? Now, what I'm missing there is I'm missing the numbers that go in front. So what I would do, if I use my Pascal's triangle, these numbers that I just came up with, that was if the degree was 7. This is B plus F to the 7. So since it's 7, all these numbers would go in front of the terms.
Are we going to be given that?
So, I'm going to show you another way around it though. All right? And so, I had 1, I have 7, I have 21, I have 35, I have 35, 21, 7, and 1. Okay? Now, I'm going to put plus signs in between all those. So now that is my expansion. All right? Yes, ma'am.
Are they ever going to give us one that's like impossible to expand?
No, they may do different pieces. Stuff. I'm going to show you a few other things. All right? But now, this took a little bit of time. This took a little bit of time, but it was a lot faster than actually multiplying B plus F out 7 times. All right? Questions on this one before we go? All right? Now, let me explain this a little bit more. All right? If I went down to the cafeteria at lunchtime or whatever, and I had $7, all right, and they're selling potatoes. They're selling baked potatoes, or they're selling fried potatoes, which are French fries. Okay? And so, fried potatoes or baked potatoes, all right? B or F. I have $7, all right? What could I spend my $7 on? Well, I could buy all 7 baked potatoes. All right, there's only one way to do that. All right? Or I could buy 6 baked potatoes and 1 French fry. Okay? Now, here's the thing though. How do I do that? Well, I could buy the French fries first and then all baked potatoes. Or I could buy all baked potatoes and the French fry last. Or the French fry in any of those 7 spots. So there's 7 different ways that I could buy 6 baked potatoes and 1 French fry. Make sense? All right. On this one, that would be 5 baked potatoes and 2 French fries. There's 21 different ways to arrange those. All right. As you're going. Or maybe I don't like baked potatoes. Maybe I'm just going to buy French fries. So there's there's one way to buy just 7 straight French fries. Make sense? Kind of see what we're going on here. So I have $7. That's my main thing. I have $7. How am I spending that $7? 4 and 3, 5 and 2, 6 and 1. What combination am I spending it? Good? So that's kind of what's laid out here. Now, go to the one right above it. All right? So you have this one right above it. you have x minus y to the fourth. Okay? X minus y to the fourth. It asks a little bit different question on this one. I'm going to do the whole expansion, but I'm going to do the part first, then I'm going to go back. It says, what's the third term which contains x squared? All right? So they only want that term. Now, how many terms is this going to have?
5.
It's going to have 5 because there's 4 there that's shown. I'm needing 1 more. So if I were to start this, okay, I'm going to have x to the 4th, then x to the 3rd, then x to the 2nd. Technically, that's where I want to end. That's the one that I want. Everybody understand that? Because it's x squared squared. Now, I'm going to go in and finish it. X to the 1st, x to the 0. Okay? Now, what's different about this problem than the other ones we've done?
There's no second, there is a second.
There's a negative. Okay? It's negative y. So I would have negative y to the 0, negative y to the 1st. Now, could I have just skipped right to this one and just said, I know y's got to be 2? We could do that because what do the exponents have to add up for? 4. How am I spending my $4? 2 and 2. All right? Or we could say negative y to the 3rd or negative y to the 4th.
How can you buy negative?
Okay? It's just the item, whatever it is. All right? You can't buy a negative y product yet. Okay? Now, if I go through here now, the last thing I got to do is I've got to go place my coefficients. Now, what's the first one and the last one always? It's always 1. That's always 1, and that's always 1. From the pattern we did a while ago, we talked about the second coefficient. What was it?
6?
It is whatever the exponent is. So it is 4 here and 4 here. Now, unfortunately, that doesn't give me the one that I'm wanting right here. Okay? I could go back and look at my Pascal's triangle. That would be fine. I could get it from there. Or what I'm going to do is this. If you notice here, this is combination. All right? We did combination the very first day of this unit. How many different ways are there to order these certain little things? All right? How many different combinations do I have? Well, the top one. What's the top one in all these? 4. Where's the 4 coming from in my problem? The 4 in the original problem, the binomial, okay? Where's this 0, the 1, the 2, the 3, the 4? Where's that coming from? Looks like the y value, okay? Looks like the y value. Could it be the x?
Yes.
If I count it backwards? Same thing, right? And so the number on top gives me the total amount, and the number on bottom is giving me the specific term, which one it is, and I can pick either of the 2 exponents there. Don't add them together. I'm going to pick one or the other. Okay? So I can go do this in my calculator. So instead of doing the Pascal's triangle, I can go in my calculator. If you remember, I'm going to clear this real quick. I'm going to go on. I'm going to go new. And no, I'm not going to save that. If we just go to our normal calculator, we were in menu and probabilities where we were at the beginning of the unit last week. Probability and combinations is where we want to be. So we're going 4, comma, choose 0. I'm going to use my up arrow key and just highlight that again. Use delete and do 1. And do that again. And delete and use 2. Do that again. And delete and use 3, so forth, and I get that. So I'm getting all those numbers. So this is how I get the numbers in my calculator. I've reset it. Okay. So the one that I'm missing that I want is the 6. So the 6 goes here. Okay.
Isn't it like into the question?
It is. It's already there. But I wanted to make sure that I showed you how to do that. So they went back. You could go back and look at the Pascal's triangle and get it. But if you don't have the Pascal's triangle, so I can get it this way, it's probably more efficient. Now, let me ask a question. Why is 4 choose 1, 4, and why is 4 choose 3, 4? Why are they the same? 4 choose 1 or 4 choose 3?
Because one
Say again?
Cause the exponents add together.
Because they add the 4, it's the same combination as 4, okay? If you had 4 things to pick, you could say, okay, you may go 4 choose and you're gonna pick 3, all right? Or you may go 4 choose and I'm gonna choose not to pick 1. So I may pick my 3 by just eliminating 1. You do that on multiple choice questions from time to time. You go, okay, I know it's not that one, all right? You eliminate that. So I can pick 3 of them, or I could choose not to pick 1. That would give me the same result. Make sense? So that's why this is repeating all the way through the problem. Now, what's going to happen with the y's as I do the exponents to the y's? Do I need this one really? No. What's going to happen with this y right here? It's going to be negative. This one's going to be positive. That one's going to be negative. That one's going to be positive. So when I have a negative in here, when I apply those exponents, it's going to make it go back and forth. And so on this one, this is x to the 4th plus 4x cubed. Actually, it's not plus, it's minus. Minus 4x cubed y plus 6x squared y squared minus 4xy cubed plus y to the 4th. That's what my that's what it would be. If I wrote it in simplistic form, if I got rid of all the extra stuff, that's what it would be. Okay? So that is my binomial expansion. Now, on this one, all it asks me to do is to find this one, so that's the answer that I would have given. Okay?
Why is the 6 positive but the 4 ones are not?
Because the negative with the y, if I square y, negative times negative is a positive. If I do 1 negative, it's negative. If I do 3 negatives, it's negative. Okay? All right? Let's keep going. I want you to do that expansion right there for me real quick. It's at the very bottom of the page. Try that one real quick. Write your B's out, then write your R's out. So here's with my B's and my R's laid out for me. How many terms do I have? We got 4. Got 1 more. All right. What are the numbers that go in front of these? 1 and 3. This one actually was probably a pretty easy one because of that idea. All right. Everything's gonna be a positive plus through that whole deal. It's symmetry. Okay. I'm going to add one real quick. If you don't have any top room at the bottom of the page, I'm going to come back to this one in just a second. But I'm going to add one. If you want to flip and go to the back page or to the blank, all right? I want to do one more with you real quick, and then we'll go. And so, if I were to give you this right here, okay, x minus 2 to the 8, all right? How many numbers are in this expansion? 9, but here's what I want you to do. I want you to find the x to the 5th term. I just want you to find that one. There's 9 terms in this, but I want you to go find the one that has x to the 5th in it. Okay? Well, if I'm going to do that, my clue is x to the 5th. What is the other part going to be? What's negative 2 going to be?
0.
How many of those?
1.
Not 0, not 1.
What am I thinking?
It's 3.
It's 3.
Oh.
Why is it 3?
So they add to 8.
Because they have to add up to be 8. Okay? So x is the first one. There's 5 of them, is what it said. The negative 2 is there. How many of the negative 2's do I have to take to be in this term? I have to take 3 of them. Because those two things have to add up to be 8. Now, the last thing, I need the number out front. Okay? What's the number that goes on top? 8. Everything I have. What number goes on bottom? 5 or 3. You could take your pick. Alright? It could be 5 or 3. Because those are the two exponents that are in here. Okay? It should give you the same. So I'm going to go to my calculator. And I'm going to go do that. And I'm going to go combination. I'm going to go 8, choose 5. Or if you did the other one, you did 8, choose 3. Got 56 on either one of those. Okay? So this green is 56. What's the blue right here?
Oh.
What is negative 2 cubed?
-8.
Negative 8. Alright? And so I'm going to have to multiply the negative 8 and the 56 together. So use your calculator. Negative 8 and 56 is 424?
440.
4 what? 448. Yeah. Negative 448 x to the 5th.
See my calc.
Got it?
Yes.
So that's that term. I didn't have to go find all 9 of them. They just asked me to go find that specific one. Okay? Now, go across the page. The binomial theorem can now be used in some probabilities. So here's the connection of probabilities. All right? I have a special die. It's got 2 red faces and 4 black faces. It's got 6 faces total. 2 red, 4 black. All right? If I were to roll it 3 times, what do my outcomes look like? Well, I could roll red, red, red. That's one thing I could do. There's only one way to do that. Red, red, red. Or I could do black, black, black. I could roll all 3 blacks. Okay? Or I could roll a combination of 2 reds and a black. So I could go red, red, black. I could go red, black, red. Or black, red, red. Okay? So any of these combinations right there would be 2 reds and a black. If I was drawing a probability tree diagram like we did on Friday, there would be 3 different paths that take me to the same result. Okay? Or I could go 1 black, 1 red, and 2 black. So I could go black, black, red, black, red, black. Okay? It asked me on this one, what is the ratio of possible outcomes? Well, I can have 1 for this one. I can have 3 for this one, 3 for that one, and 3 for that one. Or excuse me, 1 for the last one.
Also, it's just like the.
Does that look familiar?
Whoa.
That's this. 3 reds. There was only one way to get 3 reds. 3 blacks. There was only one way to get 3 blacks. To get 2 blacks and a red, there is 3 ways. To get 2 reds and a black, there's 3 ways. Okay? So you have that. Now, take it a little bit step further. What's the probability of landing on a red? Two out of 6. 2 red, or 1/3. What's the probability of a black? 4 out of 6, or 2/3. Okay? Now, if I were to go over here, these were all the outcomes that I had just listed on that previous side. So what's the probability of getting a red, red, and a red? It's probably getting 1 red. 1/3. I'm going to cube it because it's red times red times red, which would be 1 out of 27. 1 times 1 times 1, 3 times 3 times 3. Okay? I'm going to jump to the bottom. What's probably getting a black?
2/3.
2/3. So to get all three blacks would be 2/3 cubed. 2 times 2 times 2 is
Like 8.
8. 3 times 3 times 3 is 27.
Does that cube come from how many times you rolled it?
Yes. Because I'm doing 2/3 for the first one, 2/3 for the second one, 2/3 for the third one. Okay? This one right here. To get 2 reds and a black, I'd go 1/3, 1/3, and 2/3. 1/3, 1/3, 2/3. So I'd get 2 27s. Except what? Is that it for 2 reds and a black? You got all these other 2 right here. But all these have the same exact probability. So I could take this and I can multiply it by 3, the 3 different ways to get it. So this would be 6 27ths is what that one will be. Many people will give me 2 27ths for that answer, which you've done almost everything right. You just didn't say that there was 3 different ways to get that. Same thing on this one. This would be 1/3 and 2/3 and 2/3, which that would be 4 27ths. But there's 3 different ways to get it. So multiply it by 3, so this would be 12 27ths. Do something for me real quick. What's 8 plus 12 plus 6 plus 1?
8 plus 12 is
27. Is this all the probabilities? 27 out of 27, that's everything that could possibly happen in this experiment, right? 8 plus 12 is 20, plus 6 plus 1 is 27 out of 27. So I've got everything that possibly could happen there. Okay? All right.
Wait, Carson, is that thing?
Homework tonight, page 52, page 54. On page 52, it's 1 through 6, but I'd like for you to do the odds. And then on page 54, I think it says 3, 6, and 9. Is that correct?
Yes.
And so those should be good. I've already kind of shortened that a little bit. You want me to shorten it more?
The test is Wednesday?
Which ones were paid?
Odds with every other
The odds.